Alright, everyone, pause for a moment. Atlas is blinking. This is not just a figure of speech. It's not a subtle blink at all. These are significant brightness fluctuations, varying by hundreds of times in very short periods. This discovery completely transforms how we need to approach this interstellar visitor. Over the next few minutes, I'll detail everything we currently understand about it, the latest striking images, the X-ray signals that have emerged on scientific radar, the jet pattern that consistently points toward the mother star of our solar system, and, of course, the complete list of anomalies that together create a troubling picture. Get ready for numbers, images that suggest editing, and most importantly, the questions that the scientific community urgently needs to address in a public forum. The pulse, the images, and the countdown. The starting point is straightforward yet disturbing. Each day, Atlas becomes increasingly unpredictable. The critical moment approaches, with its closest pass to Earth expected on December 19th, rather than yielding answers. The new data only deepens our uncertainties. Over the past few weeks, fresh observations have come in from various locations worldwide. Recently captured images from Calabria, Italy, by Tony Scarmato, and records from Gerald Riemann in Namibia have added to the mix. An impressive collection from an observer named Ray, and sequences of frames reveal Atlas's appearance shifting dramatically over days, sometimes with a massive coma, at other times barely noticeable, and in several instances, consistently displaying a jet directed forward towards our solar system's mother star. Now we reach the part that leaves anyone familiar with typical comets without a clear resolution. The brightness graphs. There exists a communal repository of observations where the anticipated brightness curve is superimposed, with actual data measured by both amateur and professional astronomers. The result is stark. Atlas exhibits fluctuations of 4 magnitudes or more, resulting in brightness variations that can be hundreds or even thousands of times its apparent luminosity. For the editing phase, overlay the expected graph with observed data points and zoom in on the segments where the amplitude skyrockets. Caption it with recorded brightness variations up to 4 magnitudes. Why does this pose an issue for the classic comet hypothesis? Certainly, known comets can experience sudden brightness spikes. However, these are typically isolated incidents, usually accompanied by noticeable signs of fragmentation or substantial material ejection. In the case of Atlas, we observe enormous spikes without any signs of nucleus breakup. In essence, we have brightness eruptions occurring without any cloud of fragments that should be present with such activity. This situation is both anomalous and extremely rare. There are triangulation inconsistencies between spacecraft and instruments. The transcript refers to something critical but inadequately explored. The inconsistency in triangulation from different perspectives, like SOHO, stereo, A, and SDO, when an object is genuinely within the vicinity of the mother star of our solar system, its apparent position should shift predictably based on each instrument's angle of observation. This principle applies to coronagraphs, extreme ultraviolet telescopes, and visible light imaging. If 3 platforms fail to capture the same structure within the same time frame or present incompatible angular displacements, it's an immediate red flag. This could mean that the data is incomplete, or the phenomenon is not behaving like a conventional physical object. The transcripts detail scenarios where one instrument detects a bright signature or elongated structure, while another shows nothing or reacts significantly later, as if there is an unaccounted temporal offset. Such anomalies can occur due to synchronization issues, automated filtering that omits entire frames, or highly directional phenomena visible only within a narrow field. However, the patterns you've described surpass these typical explanations and must be treated as unique anomalies. The only reliable remedy is full triangulation employing raw telemetry, precise timestamps, exact pointing angles, capture cadence, and unrefined metadata. This would allow for the reconstruction of Atlas's expected position across all instruments, verifying whether its visibility or invisibility makes sense. Until such triangulation is achieved, these inconsistencies remain a major anomaly, potentially more significant than the wing-shaped silhouette or apparent acceleration patterns. Now, let's discuss the forward jet and the X-ray signal to phenomena that don't align. Another critical observation to emphasize. Several image sets depict a columnated jet directed toward our stellar system. The geometry doesn't align with simple perspective effects. It showcases a flow aimed at the mother star of our solar system, a distinctly defined and in terms of physics, this is challenging to justify with mere directionally heated sublimation. Additionally, X-ray detections associated with Atlas's behavior have emerged, typically linked to interactions between stellar wind and ionized gases. However, the intensity and profile of this signal resemble an energy source rather than just plasma oscillation. This pattern raises more questions than it offers comfort. There's also the matter of the inconsistent blinking. On certain nights, Atlas shows a diffuse coma, on others, a well-structured tail, and at times, nearly nothing at all. This systematic variation undermines any explanation based strictly on passive thermal activity of the nucleus. while Atlas has garnered attention, other significant events have transpired that complicate the narrative. The loss of contact with a Mars probe around December 6th, a solar storm classified as G1 that might escalate to G3 on December 9th and 10th, and a newly discovered asteroid called 2025XR that narrowly passed Earth on December 5th, measuring approximately 37 meters, comparable in size to the one that injured 1,000 individuals years ago. Additionally, public reports of unidentified aerial objects have surged in various locations worldwide, including Mus Geras in Australia and Marin. The sequence and clustering of these incidents cannot be overlooked. What do we face in terms of natural hypotheses? Let's tackle the question everyone poses. Is it just a comet? Here's why that evaluation falters with the current body of evidence. Brightness variations of hundreds of times would necessitate ejection of mass in quantities that, based on size estimates, would lead to clear fragmentation. Despite this, Atlas remains intact. Consistent columnated jets aimed at the mother star of our solar system don't correspond with random thermal jets formed from patches of ice. The geometry indicates a directionality. The distribution of chemicals and optical polarization entirely skips the empirical patterns associated with comets, and the energy-activity balance doesn't add up. The radiated power seems to surpass what the nucleus could absorb and convert into jets, considering its estimated size. In summary, labeling Atlas as a conventional comet would necessitate reliance on fragmented explanations, undermining the credibility of a straightforward natural model. Alternative hypotheses. Given the complexities, several possibilities should be candidly presented without arriving at definitive conclusions, serving merely as scientific frameworks, unknown natural phenomenon, or a combination of influences. A structure characterized by heterogeneous composition or geological engineering, activity induced by micromechanical mechanisms, or an artificial object exhibiting active control. Importantly, extraordinary claims require extraordinary evidence. Here, we outline potential paths without preemptively choosing answers, observations that could steer the investigation. Continuous brightness monitoring with cross-calibration, high-resolution spectroscopy during brightness peaks, sequential polarimetric mapping, searching for non-gravitational motions, and dynamic modeling. Open data exchange is crucial. If you're following observers or possess legitimate images, preserve the original files, UTC time, location, and metadata. This data is vital for analysis. Do not publish materials without the primary records. Speculation provides no benefit, while rigorous documentation significantly helps. Instrumental checks and false positives. How can we confirm that the blinking is genuine? Our first step should be to exhaust all instrumental explanations before attributing the blinking to the physical behavior of the object. Numerous artificial causes can simulate extreme brightness changes, and each presents a direct test. Promptly request that involved observatories share raw files along with complete metadata, UTC, timestamps, exposure, gain, sensor temperature, file compression, and any calibration procedures followed. If the blinking is consistent across different sensors, locations, and cameras, the hypothesis of a local artifact weakens. Practical tests to conduct. Immediately include comparing the brightnesses of reference stars in the same frames to verify absolute changes versus calibration shifts. Checking the point spread function for sensor saturation or blooming, inspecting chip logs for cosmic ray hits resulting in isolated spikes, auditing automated processing workflows, stacking background subtraction to eliminate software artifacts, and cross-checking observations in various wavelengths to ascertain whether the variation is simultaneous in optical, infrared, and ultraviolet. If independent observatories utilizing different instruments and pipelines record the same temporal variation with coherent patterns, we can then treat the flashing as intrinsic. Until that point is reached, our priority should be to preserve raw data, synchronize clocks, share metadata, and conduct cross-calibrations, all while documenting everything meticulously. Absent that, any physical interpretation remains precarious. Now I'll provide a concise recap in the exact order you requested of the known Atlas anomalies. Each item mentioned has been documented through observers and preliminary papers collectively. This list of 12 points forms a block of evidence that does not conform to simple explanations. 1. Retrograde trajectory aligned with the ecliptic. 2. Jets directed toward the mother star of our solar system. 3. Nucleus exhibiting mass outside established patterns. 4. Approach window characterized by improbable coincidences. 5. Plume enriched in nickel. 6. Gas emissions primarily consisting of water vapor. 7. Intensely negative optical polarization. 8. Entry vector coinciding with the wow signal. 9. Sudden brightness spikes accompanied by blue tones. 10. Energy balance incompatible with estimated size. 11. Acceleration lacking a corresponding cloud of ejected material. 12. Persistent columnated jets at significant distances. Individually, some of these points may have marginal explanations, but combined, they form a puzzle that warrants an open public investigation, transparent data sharing, and thorough review. Atlas is blinking. Atlas is emitting signals that challenge our existing models. Atlas presents 12 anomalies that collectively challenge simplistic interpretations. The appropriate response is a transparent investigation, avoiding the temptation to accept easy answers while also refraining from jumping to conclusions without substantial data. If you possess a theory, observation files, or suggestions for whom we should contact to gather more data, please leave a comment. Share and comment on this video. The more eyes and hands involved in responsible data collection, the greater the chance we uncover solid answers. In upcoming videos, I'll return with analyses of the spectra that have come in, comparisons of brightness, curves, and a panel with experts to discuss the necessary instrumentation to test the technological hypothesis. Until then, keep recording, document diligently, and maintain your curiosity. Science thrives when everyone engages with data and rigor. I'm signing off.